Okay, so we have 40 minutes, and I don't have the exercise for you. So if I keep talking for 40 minutes, then you won't learn anything. So let me try something else. Okay. So let's get you started with some example. Okay. Okay. This is called so like previously people believed that number theory is a branch of mathematics with no application. This is like a useless branch of mathematics. Like there was one famous mathematician called, his name is George Hardy. He said like mathematics has no application. It's like the useless sign. Like, and he also write a book called Mathematician Apology. The whole book talks about like he's sorry that math has no applications, like because in the old days, like the only math that you need is when you want to calculate the trajectory of the cannon or something like that, or easy stuff in physics. But like math, like number theory, is like seem to be something like that has no applications. But mathematicians learn it or worked on it because of its pure beauty. Okay, and that's the reason we learn about it. Okay, no, not actually. But turns out that the useless math is the framework for, like, is the foundation for everything that we have today. Like without this kind of math that we learn, that there will be no e-commerce. You cannot buy stuff. You cannot, type in your password without revealing with the password to the people from the computer centers. Okay, so you cannot do anything. You don't have like, so this is like public key cryptography. Is different from cryptocurrency, but it's kind of related. But if you don't have RSA, then you don't have cryptocurrency. Then you don't have Bitcoin, and then you don't have like bunch of Bitcoin bros, like some crazy guy. So you don't have that, but you don't have some other things, a lot of things. You probably can't have the like the mobile wallet or anything. You really won't have the คนละครึ่ง plus something. Okay. You won't have smartphone, I think, because the reason people have smartphone is that you can log in securely, like, but if you cannot log in password with some security, then you don't, it will be impossible for most of the thing. Okay, so we will learn the foundation of this kind of this technology, and we see why it works, and we also see the math behind it. Okay, but since we only have 2.5 week left, so roughly 5 lectures, we won't cover much. Okay, but let me tell you, give you a motivation on this based on what we call public key cryptography. Okay, so previously people know cryptography for a long time. Okay, like if you want to send some secret, like you have a troop somewhere and you want to tell them to do something, and if you use telephone or if you do the radio broadcasting, then the enemy can intercept and hear all the messages that you talked, right? So you start using some way to get them confused, right? So instead of like saying you should go and kill everyone, then you say like it's time to have breakfast or something like that, and then that's a kind of like keyword that you can use. Okay, like the Romans has a way to do some encryption based on the Caesar encryption. You write the code in one way and then you decode it in the other way. So there are many ways to do that, but most of the time, if you want to send secret message, okay, so you have two parties. Here, we usually refer to the two parties as one is called Alice, the other is called Bob. You can guess, so Alice is A, Bob is B, and there will be some guys or someone try to intercept the message, and that's gonna be E, Eve. Okay, but if Alice want to send something to Bob, okay, my password is something, okay, and this Eve can hear it. Yeah, then I'm good, right? Okay. So the only way Alice can tell Bob, give the password to Bob without having Eve to without revealing it to Eve is to use some form of encryption. Okay. The standard way of encryption is called, you need a key. Okay. So if you want to encrypt something, you need some secret. Okay. And if you can maintain that secret, so we refer to that as a key. So if Alice has a key, okay, and Bob also know the key, they can use this key to encrypt. So you have a message. My password is blah blah, and you take this key and you encrypt it. When you think of encryption, you can think of it as put it in some bag and seal it. Okay. So, and then you send this to Bob. Okay. Bob with the key. Okay. So he can take out the message. Okay. So this is a typical way to do encryptions. So two people share the same key, and if they have the same key, they can encrypt and decrypt. There are many ways to do that. Okay, but you shouldn't use the same key for many times. But anyway, we just leave it out. Okay, but so if Alice knows Bob, they can meet in person, and okay, this is my key. Okay, then they can communicate securely. But if you're on the internet, it will be really hard to have the same key. Okay, if you want to connect to Google server and you have to share the same key with the Google server, how can you do that? Or if you want to send, so suppose some secret and you want to send the secret to someone without revealing it to someone else, so it will be really hard to do that. So the fact that you need the same key is a thing that kill every applications, because it's really hard to share the same key. Okay? So that's the early days of maybe before the internet. Okay. Okay. So people is trying to come up with a way to solve this problem. Okay. And there's a scheme called, typically referred to as public key cryptography. So this scheme is referred to as private key cryptography, because you need to keep the key private, okay? And they have to share the same private key so that they can talk. Okay. Now, but with public key cryptography, things become easier, but nobody knows how to actually implement it. Okay. But the idea is there, but nobody knows how to implement it until the three guys came along. So the three guy has the name RSA. Okay. So the public key cryptography works like this. Instead of having a key and they have to share the same key, you have two keys. One key is called public key. Public key. Another is called private key. So let's refer to this K1 and K2. And this key is so in this case, encryption and decryption is symmetric in a way that if you want to encrypt, you use a key. If you want to decrypt, you use the same key. So sometimes people refer to this as symmetric key cryptography because you have one key, okay? But now this is asymmetric encryption. Means that if you use the public key to encrypt, the only way you can decrypt is to use private key. If you use private key to encrypt, you can use public key to decrypt. So you have two keys, it plays different roles. If you use one key to encrypt, you need another key to decrypt. Okay, this is like some pretty crazy idea. But if you can have this, so these two keys has to be generated together. It's not like, okay, this is my key and then you have another key from somewhere else. No, it has to be created at the same, not at the same time, but they have to be like jointly formed in some way or another. Okay, they are in a really tight relationship. Okay, so you have public key and private key. Okay, as the name suggested. So let's look at the case when at least one is send something to Bob. Okay, Bob has two keys. He has public key and he has private key. As the name suggests, he has to keep his private key private. Okay, if someone has his private key, then you're done. So if you are a Bitcoin bro and you lost your private key, then you're done as well. Like your Bitcoin will be gone forever. No way to take it back. But the public key is public. Okay. So you can post, like Bob can tell everyone, like there's a directory called Bob, and he say if his public key is 1 2 1 1 3 4, he can say, okay, this is my public key. Okay, so anyone who wants to send a message to Bob can use this public key to encrypt. So Alice has a message M. She wants to send to Bob, right? So she encrypt this message with Bob public key. So let's write this encrypt M with public key, right? With K1, right? Encrypt and send to Bob. Okay. Now along the way, maybe Eve comes along and she see this message. Okay. Wow, that's a message. But she cannot do anything with it because the only way you can decrypt a message that is encrypted with public key is to use a private key. But she doesn't know Bob's private key. Okay? This message looks like a random message, some garbage to Eve. So she can't do anything. Okay? But when Bob receives this message, okay, Bob can decrypt it. So he can call decrypt with the message MK1 given the private key, and he'll get M back. So you encrypt with the public key, decrypt with the private key. And you can announce your public key to anyone. Okay. Knowing your public key doesn't sacrifice any of your privacy. Okay. Yeah. Unless they have some really good quantum computers and a lot of money to run the computer and the time, and nobody knows how to do that. But anyway, so this is how thing works. So, and in terms of like Bitcoin, right? So a Bitcoin has each Bitcoin wallet is a number, and that number is basically the public key. So the Bitcoin wallet, like the address, Bitcoin address, that's the public key. So you can know the public key of anyone, but you cannot perform any operation on that unless you know the private key. Okay. So same thing here. So Bob can receive message from anyone who knows his public key. Okay. So you don't have to share the same private key, right? You don't. So there's no need for you and Bob to meet in the same room to give password, right? So you can just announce, oh, okay. So if you want to connect to Google securely, use this public key. and you can use that public key to send to Google, and then everything is safe. But the harder part is like, how do you know that the public key of Google is actually the public key of Google? If you ask someone what's the public key of Google and you trust him, then maybe you get the wrong public key and use your message. Say Alice wants to send something to Bob, but she asks if what's Bob public key, and if just give her public key. So when Alice encrypt, it can just read the message, right? So you did. Okay. So on the internet, that's another problem. Okay, but the internet is safe because on your browser, every browser has already you have a public key of a bunch of authority inside your web browser. Okay, so that makes everything safe. So you can know that this is the public key of Google for sure because it's related to the public key inside your web browser. So if you download the web browser from a legitimate website, so you have the correct certificate and everything works. But if someone gives you the web browser to use and you don't care about it, maybe you have the wrong public key, and then when you go to the bank, type in your password, people can get your password. Okay, so it's important to use the right web browser. Okay, so you go to someone, like it's exactly like if you go to the library machine and you just log into your bank account on the library computers, then tomorrow you won't have any money left. Same thing. Okay. All right. So how does this work? Okay. So let me show you how it works. Okay. Next time we'll do some practice here. Do you have do everyone has a laptop or me laptop, me iPad, meอะไร Okay. So next Thursday, bring one. Okay. I'll show you today, and then you work on it next time. Okay. You generate. พฤหัสนี้บอกว่าพฤหัสเราเรียนพฤหัสใช่ไหมใช่ครับ next time on Thursday. Okay. So let me show you how everything works once, and then on Thursday you work on it. Okay. And then everyone will generate. Everyone will create a key pair, public key and private key pair, and you send me some message, and I'll send you some message. And if you can decode it, then it means like your key works, and the way you sort of like understand how RSA works. Okay, but that's the coding part of it. But we will learn the math behind it. But to get you a little bit excited, you should see how it works. Okay, so let me show you one example. So let me describe it really quickly to you. Okay. So RSA. So this is it's the name of the mathematicians. So no, they're Americans. So this is Adelman. This is Shamir. This is Rubes. These three guys. Okay. So let me tell you the two operations first. Okay. So how you need a public key to do the encryption, and you need a private key. Okay. So public key has two numbers. Okay. So it's called M and N. Also, the private key also has two numbers. Let's call let's call it EN, and then DN. Okay. So E is encryption, D is decryption. Okay. Public key has two numbers. Private key has two numbers. N will be some number which is really big numbers. How big is it? So it should be like a number that is like a few thousand digits long. It will be really long. Okay. The longer, the safer. Okay. I'll tell you later how to come up with that, but it will be a really big number. E will be some small number. D will be some number depending on E. So E and D has to be like really related. Okay. So if you have these two numbers, if you have these two keys, okay, the message that you want to send will be a number as well, M. But this will be a really big number as well. So if you want to send a message like hello world, you have to encode this into a number. Okay, it will be like some number 1, 1, 2, 1, 5, 1, 6, 7, 8, 2, 10, 2, 9, some really big number. Okay, like 1,000 digits long. So if you have a really long message, it has to be broken into a lot of numbers. Okay, but it will be some number M. Okay. To do the encryption, it's really easy. So you want to do encrypt. You want to encrypt message M. So it's basically you take M to the E power. So you multiply M E time. But E is going to be some really big numbers. So to do that, you need some really good algorithms. And then you mod N. Do you know mod?
Yes.
So this is like in Python, it's going to be like this. Okay. This is encryption. And what exactly is decryption? So suppose you have a message that has already been encrypted. Let's call it MK. Let's call it M prime. This is not M prime. So to do that, to decrypt, so you just let not use M. Let's call it Q. Oh no. R. Let's call it R. Okay, to decrypt a message R, so you just raise it to the power of D, and then again you mod N. This is the very mathy, right? So you take the number and you raise to some power and modulo N. When you decrypt, you do that, do the same thing. Okay. Okay. This is it. This is how you encrypt and decrypt. You just do some, exponentiation. But let me tell you what is the public key and the private key. So let me tell you N first. So the reason why people believe that RSA is safe is because of N. N is a really big number, okay? But not just any number. So to come up with N, you pick two prime numbers. But they have to be really big numbers like P and Q. And we let N equal PQ. Okay. By the way, if people, so the public key, this public key is going to be public. People will know E and N. Okay. But if people know N, and if they can factor N into P and Q, then you're done. You're done for it. They can break your password. Okay? So the reason why RSA is really hard is because N is really large and nobody knows how to factor N into two prime number. So N is a product of two prime numbers. These two prime numbers will really, really large, like 1,000 digits. And you multiply it and you get N. Okay? So that's the hardest part. So if you take one really big integer and you can factor it, then you can break RSA. And that's what people talked about quantum computers. Quantum computers can do factorizations really quickly. In theory, nobody knows if you can do that in real life. But if you can build the quantum computer that do that, then you can break RSA. But RSA is like a few thousand digits, and it requires quantum computer with like 1,000,000 qubits. So it's gonna be a long time. Not in my life, I guess, but maybe in your life, because I'll die next year. No kidding. I should, but nobody knows, right? If I die next year, then you know that I told you first. No kidding. I need to cut it out of my YouTube. Otherwise, like people will, oh, that's great. He knows he'll die next year. Okay. All right. So pick two prime number and we let n to be this, and we let e. We pick e. E will be some small numbers. Typically, it will be like 6, 5, 5, 3, 5. So this is numbers e. Just pick this number and then we calculate d. But what is d? D will be this term. Currently, you have no idea what it means, okay? But after we finish this course, you should, like, when you see this, you're like, oh, okay, I know what it is, okay? You might not know it now. There's a function that calculates this, okay? But after next class, you see what it is, okay? And this is it, okay? This is how you generate the key. So pick two prime numbers, let n be pq, pick e, everyone use this as an e, and then calculate e based on this formula. It's gonna be, the name of it will be what we call the multiplicative inverse, modulo this, okay? But don't worry much about it, okay? After you have this, everything works, okay? So let me show you how I would do that in code. นี่เนาะนี่จะเป็นคุณจะ will use Colab Google Colab, you know how to use it, right? Okay, great. So yeah, so before we start, okay, so before you start, let me tell you once again, this what we experiment is called the textbook RSA. So it's RSA version, student version. Okay, you don't implement this and use in production. Okay, don't ever try to implement cryptographic algorithms on your own and use it in production because you'll be hacked. So there are many ways to, like, this stupid implementation thing will get hacked. So it's unsafe, totally unsafe. We'll do that just for educational purpose only. So don't write your own cryptographic primitive. Use libraries. Even though if you use libraries, you can still get hacked. So yeah, ถูกแฮกแน่นอนครับคือถ้าเอาโค้ดที่ไม่ใช้ชิบหายครับพูดคำเดียวว่าชิบหายเหมือนถือปืนเตรียมยิงหัวตัวเองมา It's like you holding your gun to your head and wait for like someone to, like, you know, say hello and then you just shoot yourself. So don't ever implement this yourself, okay? In no circumstance should you do that. All right. So let me show you. So to first, before you can use RSA, you need to construct a key. Okay. So in real life, if you want to use RSA in your machine, like if you want to send message, like using have you used GitHub? Use GitHub, right? Do you use public key with GitHub? You know how to do that? So how do you generate the public key?
OpenSSH.
Yeah. When you do the using OpenSSH to generate keys, that public key is the same kind of public key that we are talking about. And what you put in GitHub is the public key. So GitHub can verify that you are exactly who you are because you are the only one who know the private key, right? And when you use OpenSSH to generate the key, OpenSSH do some randomization to pick a really big param number and stuff like that. Previously, sometimes when you actually want to do that, OpenSSH needs some randomness, like in the old days you need to like move your mouse, stuff like that. But the newer version might not need that, but you need some randomness so that your key is like sort of like safe. Okay. I'll talk more about randomness later. Okay. But you need randomness because you need a way to pick a random really big palm. So you need 2 palms. So here, this is one example, but this is not big. This is like extremely small. So in the beginning, you experiment on how to send a message, and then we will do here key pair generations. So you need to pick 2 prime numbers. Okay. So this will be my secret, complete secret, and then I'll set n to be this. Okay. So this is my n. Okay. And then I'll pick e. E will be some numbers. So let's use this 65537. So this is like 2 to the 16 plus 1, I think. And then I need to compute e, but e will satisfy these equations. So it will be something crazy. And then this is the thing that we get. And my public key is this. So this is my public key, and this is my private key. Okay, my private key. And how am I going to use it? So I need to keep this thing secret, and then I can tell everyone about my public key. And if anyone want to send me some message, they can do this. So let's do that. So I should announce this, and then if anyone want to send it to me, they can put it in here. Oh, sorry. And if this will be my message, like. So this is my message 120 and want to encrypt. When I want to do a encrypt, so where's my encrypt function? So my encrypt function is just the just raise the thing to the power. So this is the message after the encryption. Okay. How can I decrypt? So I can decrypt it easily. So print. So I decrypt this message with the key D and N. So I get the same message back. Okay. Okay. But this one looks, the message after encryption looks really random, right? So this is the original message. So let's change it a little bit. So let's see how things change. If I change the message to be change this to 2, so the message like look completely different, right? And after decryption, I get the same thing back. Okay. But in real life, this will be a really large number, extremely large number. But this is like just for some practice. Okay. What you learn is gonna be like why this works, and you see the meaning of this thing, like mod, stuff like that, e modulo, multiplicative inverse, blah 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 blah. You learn what it is, and you learn how to compute this, and you can write these functions. So this function is like some function that I took from Wikipedia. This is called extended Euclidean algorithms. It's an algorithm that typically used to compute the greatest common divisor, GCD. We learn a lot about GCD, and we use Euclid algorithms, but the Euclid algorithm has the extended version that also output something nice for us. So it is used to compute the inverse here. Okay, so that's it. That's for the introduction for the second part. I hope you bring your laptops, or you don't need a laptop. I think you can use iPad on Google Colab. I think you can use iPad, but it will be a pain if you don't have keyboard.